pressure in gases. Here's in CI, it is also important in oral pressure at is having a different formula in comparison of solid and liquid. Okay, so here is a different formula for pressure in gas. Okay, now for example that I'm giving you one example. Okay, you need to understand that what is the amount of or the value of atmospheric pressure. It is always 1. Okay, so you need to understand always that 1 atm, 1 atmospheric pressure, the atmospheric pressure's value is always 1. You need to remember it. Okay, as we are talking about gas, so in gas the air includes, and about the air the atmospheric pressure is always 1. Okay, now I'm making a figure to understand the formula. In this video I am totally trying to make you understand what is the formula and why the formula, how the formula is formed. Okay, now for example I'm making a figure. Here we go. This is completely filled up with water. Here same, the water is present. Okay, so this is the force and this is the force applying on the liquid. You need to pay a very attention. Okay, this is exerting the 10 newtons force. Here we need to find it. Okay, and its area of the little one is 2 centimeter square. Here is 200 centimeter square. Now you need to remember that how we need to find out the value. This we can consider as the question. We need to for example this is the question and we need to find the pressure in gas. So how can we find it? Here is a formula applying to answer the every question, and this is the very easiest one. This is represented as force 1 upon area 1 is equals to force 2 upon area 2. Force 1 area 1, force 2 area 2. Now making the data, you have to not make the data in the question, you have to sense the data. Force 1 will consider obviously 10 Newton. Area 1 will consider obviously 10 Newton applying on 2 centimeter. So it's the area 1. If you are considering force 1 as 10 Newton, which is actually, and you are considering the force 2, which you need to find out, and here is the area 2, which is given 200 centimeter square. Remember about the SI units. Okay, now we will put these value In the formula, how? 10 upon 2 is equals to F2 upon 200. Here 200 is dividing by force 2, so we'll shift there. It will, sorry, it's not about minus 10. It will multiply there. So it will be created like as this. 200 multiplied by 10 upon 2 is equals to force 2. This is we need to create out. Okay, now do you think something is happening here? If you are expert in maths, obviously you need something here. Yeah, obviously it's dividing. 2 ones are 2, 2 hundreds are 200. So the answer will be 100 multiplied by 10 is equals to F2. The answer will become 100. Something is missing? Obviously, as I have told you about the force, the SI unit of force is always Newton. And now the answer is completed. And I am also hoping to get the full marks, which I will. Now in the figure, one more thing I need to talk you about is you need to remember that pressure of you need to remember this, that pressure of atmosphere is commonly higher than pressure of liquids. Is it making you sense? Obviously. How is making you sense? As you can look in the figure at the diagram that here the atmospheric pressure is always one, which is exerting, having more pressure than the pressure of liquids. Otherwise the liquid will move upwards, will extend towards the air. It's having more pressure, that's why it's controlling the water. We can also take the example of gravitational field strength, but it's another thing. The one atmospheric pressure, or we can say that atmospheric pressure is higher than the pressure in liquids, is the most important sentence you need to understand. This is the liquid under control. It's not moving out from the bowl. Why? Because the pressure of the air is more, the air resistance pressure is more than the pressure in liquid. You need to understand this to also answer some logical questions or some questions which will be dealt by the common sense. So this how one more thing which we need to understand in the pressure of liquid is further only the last but most important thing which you need to understand. One thing in pressure of liquid you need to understand that as we have learned the formula, the pressure is equals to density multiplied by gravitational field strength multiplied by height. For example, here we are having 1000. What is the densities for SI unit? Kilometer per meter cube per cubic meter, what else you want to say. Okay, and now it will be divided by 10 gravitational field strength. Formula SI unit is Newton per kilogram multiply by and we'll take the height, for example, 3 meter. So you need to also understand the SI unit while calculating the values. Like for example, you have calculated the value. Okay, so now the answer is coming 30,000. So if you will write kilogram, Newton per kilogram, if you will write Newton per kilogram 30,000 for example. Okay, now it's the answer. So is it reliable answer with the SI unit? So it's not problem. Yeah, I will always force you to write the answer in Pascals, because the Pascals is the SI unit of pressure of solid, liquid and gas. If you will write in this form, it is also acceptable, means the examiner will not cut the mark, obviously, but I think so that you need to write in a proper manner Pascal, while it is also a reliable and a correct answer. So I hope so that you understand the video. If you have some typical confusions, so just comment below and you just wait for the reply. Thanks for watching.